So again, good afternoon. We're going to continue again with slope of a line. Again, this word slope. A lot of times it's denoted by the letter M in algebra. Remember, it kind of refers to like if you're driving up a hill or if you're skiing down a mountain. Those steepnesses also have this linear connection, and that steepness also translates into the steepness of a line. So slope for us is going to describe the steepness of a line, and we're going to be using a coordinate plane to draw our lines. As we talked about earlier, if we had a line traveling from left to right and it's kind of going up or increasing in value, we call this a positive slope. A lot of times we'll use our hiker. Notice how he's climbing uphill. A hiker is going to identify us as a mental image that we have a positive slope. This next example, I have the order pairs 3, -1, and the order pair -4, 2. Those are my 2 points. Now, if I want to identify the slope of those, the slope of the line, what I need to do is find the change in y to the change in x in my values here. So, to find the slope, I have to move from a point to another point on the graph. And these are the 2 points I've identified. Now, I could identify other points on the graph, but that's the only 2 I've identified at this point. But it doesn't really matter what points you identify. The slope should always be the same. The slope of a line is unique. It's only one answer. So if I start at this point and I rise up, looks like I have to rise up, looks like 3. And then I have to run over. So it looks like I have to run over, looks like 3 and 4. So if I move 3 and 4, it looks like that's a run of, and I move left, so it's going to be a run of -7. So that's how I went in the upward direction, that's a positive direction, but notice how I went to the left, that's a negative direction. So, and I kind of use my y-axis as a kind of an eye, as an aid. So that's how I went 3 and then went 4. I can just do that 3 and 4 together to get my 7. And since I went left, that would be a -7. So my slope for this line is going to be a 3 over -7. But most commonly, we just put the negative out in front. And we can just call it -3/7. A lot of times if I'm doing math, I will probably denote the numerator as being my negative. I usually don't like to have a negative in my denominator. I usually put it out in front or on top. I mean, this is not wrong, but typically in notation, it's usually out in front or on the top. As we also said, I can find the slope of this line if I know 2 points. And I do have these 2 points. So 3, -1 is my point 1. At least I'm going to call that point 1. If I call that point 1, then this has to be then my point 2. So I'm going to call -4 2 my second point. So this is going to be my x1, y1, and this is going to be my x2, y2. So using my formula says go y2 minus y1, so I have to go from y2 to y1, so that's 2, take away -1. On the bottom we have x2 minus x1, so that's going to be a -4, take away 3. So on the top they'll say we have that double negative again, that's going to be the same thing as 2 plus 1. And that's going to turn into a 3 on the numerator. And a -4 and a -3 does indeed give me a -7. So my slope does give me that same thing, a -3/7. Notice how that's a negative slope. A negative slope should describe a decreasing graph. So notice if you move from left to right, the graph is kind of going in a downward motion. That's referred to as a negative slope. Also, we refer to that as decreasing in value. It's going in a downward or decreasing motion. A lot of times, decreasing, I use my little skier for that. Skier kind of goes downhill. So if my skier fits the situation, that's going to be described as a negative slope or a decreasing slope. So for most of us here, the concept of positive and negative are going to be more of the common terms. Decreasing and increasing come later, but right now we refer to positive and negative slopes as important terms to pick up on. So stay tuned for our next lesson.